Okay, welcome back. Now, we're going to start talking about approximating area under the curve. So one of the things we're going to introduce is some terminology that you need to understand because this is used a lot in approximating areas and it comes up quite a bit later on in calculus. So we're going to use it now. It comes up over and over and over again in Calc 2 and Calc 3. So just pay attention, know it now, memorize it, because if you plan on going to Calc 2 and Calc 3, then this will help save you some grief if you learn it now. Because then in Calc 2, when we start revisiting this stuff, it'll be easy, okay? And it'll be old hat because you've seen it before and it won't be a big mountain to climb. This is one of the things I see with students all the time is they don't prepare, they don't learn this stuff, and then they regret it later on. So please pay attention, make sure you understand this, because again, this is going to come up over and over and over again. Okay, so I'm setting up the terminology so you understand the development of area under the curve, and this is going to translate into other things later on. Mostly, like for Calc 2, we're going to talk about probability, which turns out to be the area under the curve. We talk about value change, total change in profit or in revenue. That's going to end up being area under the curve. Centers of mass, okay? Finding centers of mass is going to be as well ended up being area under the curve. And so all of this is going to be related. So again, this is the beginning. So what do we want to do? Well, the first thing we want to do is we want to be able to take an interval. Let's say we want to find the area under this curve. Well, the first thing we want to do is we want to be able to divide the interval, the closed interval a to b, into subintervals. How do we do that? Well, let's say we want to do n subintervals. Okay, well, we're going to choose values of x in between a and b. So let's just do this. Okay, and so the first one is going to be x1, and then x2, and then x3, and x4, and so on, all the way to x of n minus 1. A we call x0. B is equal to x of n. And so what we end up having is we end up having n subintervals. Now how do we get those n subintervals? Well, there's a formula. So if I want n subintervals, and we call this, we want to know, hey, how big is our subinterval, right? So we want to find if we want so many subintervals, let's say n, and we want to know how, because again, we want regular intervals. We want them all to be the same width, okay? So the way we do that is we take the range of the interval and then we divide it up by how many intervals we want, n. So we get this b minus a divided by n, right? That's how we subdivide any range, right? Now this, we give it a notation. This is called delta x. So in this case, when we do this, each one of these distances, the distance from x0 to x1, x1 to x2, x2 to x3, and so on, will be delta x, okay? So that's important to know. Also, we can find the value of any one of these x values, right? Any one of these subintervals, we can find where they start by using the delta x and our starting point, right? So a, right? So if I wanted to find the value of each one of these x values, well, I start with the initial value a, which is x0, and I can say, hey, I can find x of I by setting it equal to x of 0 plus whatever multiple of delta x. Okay? Because remember, each width is delta x. So if I want x0, well, I is going to be 0. So it'll just be x0. This will be 0. Okay? If I want to find x1, well, it's going to be my starting point plus 1 delta x. So 1 width, and so on. So that's another useful formula. Okay? Now, let's go into the definition here. So definition 1 says a set of points P, capital P, which is denoted by using set notation of x sub I. These set of points for I equals 0 to n with a equal to x sub 0 and b equal to x sub n, and then x sub 0 is less than x sub 1, which is less than x sub 2, all the way to less than x sub n, which divides the interval, the closed interval ab, into n subintervals of the form x0, x1, x1, x2, and so on and so forth, all the way to x sub n minus 1, x sub n. This is called a partition. So this set of points that I just described is called a partition of the interval AB. Okay, so there's one definition. Now, if the subintervals have the same width, as in the way I described up here, then we would call P a regular partition of the interval AB. Okay, so that's going to be important terminology to know going forward. Okay? That's it. Have a great day.